Okay, so shown as a pictorial view of a hexagonal pyramid, the front elevation and plan are given, projected auxiliary plan, okay, in the direction shown. So we have a direction up here, okay, so the viewer is going to be looking 90 degrees, okay, and projecting whatever view they see here is going to be projected out here. So we have to set up a new x1, y1 line. So an auxiliary plan, okay, always projected from elevation, okay, always projected from elevation. So what we need to do then is just set up our set squares, or if you have a sliding set square, use it, whatever you want, okay, and project each point back onto the line. So on our xy line, okay, we're projecting our points across, all our points across. Make sure that they're all perpendicular to the x1, y1. They have to be 90 degrees or perpendicular to the x1, y1. Okay, so if it moves, fix it like that and check it again. Okay, so now we know along this line, along point O, which is the apex. Okay, so O is going to be along here somewhere. So we don't know how far up it's going to be. So we know 2 and 3 are going to be along here somewhere. We know 4 and 1 are going to be along here somewhere. And we know 5 and 6 are going to be along this line somewhere up here. But we have to find the distance. So in an auxiliary plan, we project it from elevation, but it's still a plan. So what we need to do is take our distances and plan. So first of all, we'll take O, so O is on this line here, our apex. So from our xy line, always take the distance from our xy line. To make life easier, we take that distance for xy line from there to there. So on our x1, y1, we'll mark that. That point there is going to be O, our apex. Next then what we can do is take point 1 from x1, y1, see there? So we're going to be taking the distance from our xy line from 1. Follow it along the line 1, and that's going to be 1 in our auxiliary plan. So we have to do that for all our points. So we're going to take 2. That's going to be 2. Then we're going to take 3. So 3 is along the line from x and y1. Mark that. That's going to be 3. And then we take 4. And that's going to be 4. So next thing we need to do is take 5 and 6. So there's 6. And then we have 5. So that's all our points brought across. So all we need now is to find out, if we were looking in here at surface A, what would we see? Well, we definitely see the apex. So if we can imagine, that's O, so that's our apex. Then we can say this is 6, this is 5, this is 4, this is 3, and 2 and 1 are at the back there as well. So we would definitely see surface 0 to 6 and 0 to 5. So we can heavy that in. Okay, so that's surface A. Okay, we know then we would see 5 and 4 are joined, and 4 goes back to the apex, so we can head that in. Then we know 1 and 6 are joined, and that will go back to the apex. Okay, so what are we missing? We're missing our hidden detail. So we know 4 and 3 are joined. You can see it in the 3D view. Join that back together. 3 and 2 are joined. And 2 and 1 are joined. So you join that back together. Okay, so as you can see, A is that surface. This surface here, 5 to 4. I'll just shade that in orange so you can get a good look at it. That's that surface there. We know we'd see the other surface at the back. So that's that surface there. The rest is hidden detail. So we know edge 3 to 0 is there, but we can't see it, so it's hidden detail. And 2 to 0 is there. Can't see it, so it's hidden detail. I'm going to add that in there. And add it in here. Okay, so that's my question complete.